Picture the night sky. All those stars, billions of them, stretching in every direction. You can look at them. You can photograph them. Scientists have mapped them, named them, measured the light leaving them millions of years ago. Now, here's the problem. Everything we've ever seen in the universe, every star, every planet, every galaxy, every atom in your body, all of it, everything we've ever detected or measured or touched in the history of science, adds up to about 5% of what's out there. The other 95%? We have no idea what it is. Welcome back. I'm David. This is Stranger Than Fiction. And today, we're going after the dark. Last episode, we broke your brain with 5 science facts: time dilation, quantum mechanics, a brain that makes decisions before you do, a universe that's trying to kill you, and the fact that you are, literally, made of dead stars. If you haven't heard it, go back and listen. I'll wait. Today, we're going deeper. Into the dark. We're talking about dark matter and dark energy, the 2 biggest unsolved mysteries in all of modern physics. Together, they make up roughly 95% of everything that exists, and we know almost nothing about either of them. We also have 3 more reality-breaking facts lined up. One about the scale of the cosmos that will make you feel very small, one about a signal from space we still can't explain, and one about the fate of the universe itself. By the end of this episode, you will understand the universe slightly better and be significantly more unsettled by it. Let's go. Let's start with the numbers. When cosmologists, scientists who study the large-scale structure of the universe, add up all the ordinary matter they can detect, all the stars, all the gas, all the planets, all the dust, all the black holes, they run into a serious problem. There isn't enough of it. When scientists look at how galaxies rotate, they expect the stars on the outer edges to move slower than the stars near the center, because there's less mass pulling on them out there. That's how gravity works. It's how our solar system works. Mercury moves fast. Neptune moves slow. But galaxies don't do that. The stars on the outer edges of galaxies orbit at roughly the same speed as stars near the center, as if there's a massive invisible halo of extra mass surrounding every galaxy, keeping those outer stars from flying off into space. In 1933, Swiss astronomer Fritz Zwicky first noticed this problem. He called the missing mass dunkle Materie, dark matter. But for decades, nobody took it seriously. Then, in the 1970s, astronomer Vera Rubin spent years meticulously mapping the rotation of hundreds of galaxies. The results were undeniable. Every single galaxy showed the same anomaly. The math only worked if there was a massive amount of invisible matter holding everything together. Today, the best estimate is that dark matter makes up about 27% of the universe. Ordinary matter, everything you've ever seen, is just 5%. And here's the truly humbling part. We have never directly detected a single dark matter particle. Not one. We know it's there from its gravitational effects, but we have never seen it, captured it, or identified what it's made of. Dozens of experiments have been built in deep mines around the world, shielded from cosmic rays, trying to catch a dark matter particle passing through. So far, nothing. We are literally living inside an invisible cosmic web that we cannot see, touch, or understand, and it makes up more than a quarter of everything that exists. If dark matter is mysterious, dark energy is its deeply unsettling older sibling. Here's the setup. After the Big Bang, the universe started expanding, everything moving away from everything else. common sense, and gravity would suggest that over billions of years, all that matter pulling on itself should slow that expansion down, maybe even eventually reverse it. A big crunch. In 1998, two independent teams of astronomers were measuring the expansion rate of the universe using a special type of exploding star called a Type 1a supernova, which always explodes with a known brightness, making them perfect cosmic measuring sticks. They expected to find the expansion slowing down. Instead, they found the opposite. The expansion of the universe is accelerating, not slowing, not steady, getting faster. Something is pushing everything apart. Something is overpowering gravity on the largest scales and driving galaxies away from each other at increasing speed. Scientists called it dark energy, and it makes up roughly 68% of the universe. The discovery was so stunning that the teams were awarded the Nobel Prize in Physics in 2011. It is one of the most important scientific discoveries in human history. And here's the unknown fact that gets me every time. We have no idea what dark energy is. We don't know if it's a property of empty space, a new field, a new force, or something else entirely. We have a name for it. We have measurements of it. We have zero understanding of what it actually is. The cosmological constant, Einstein's original term for a repulsive force in space, which he added and then famously called his greatest blunder, may actually be the closest description we have. Einstein was right for the wrong reasons, and here's the consequence. If dark energy keeps accelerating the expansion of the universe, in roughly 2 trillion years, every galaxy outside our local group will have moved so far away, so fast, that its light will never be able to reach us. Future civilizations, if any exist, will look up at a completely empty sky, with no evidence that any other galaxies ever existed. The universe will have erased its own history. Let's pause for a moment and talk about scale, because I don't think most of us have ever really confronted how big the universe is. Our Sun is roughly 1.4 million kilometers across. You could fit about 1.3 million Earths inside it. Our solar system, from the Sun to the edge of the Oort cloud, is about 2 light-years across. Our galaxy, the Milky Way, is roughly 100,000 light-years across. It contains an estimated 100 to 400 billion stars, and the Milky Way is one galaxy. The observable universe, the part we can actually detect, contains an estimated 2 trillion galaxies. 2 trillion. Now here's the unknown fact. The observable universe is only observable because of the speed of light. We can only see as far as light has had time to travel since the Big Bang, about 46 billion light-years in every direction. But the universe almost certainly extends far beyond that. We just can't see it. How far does it go? We genuinely do not know. Current estimates suggest the total universe could be at least 250 times larger than the observable portion. Some models suggest it could be effectively infinite. And here's the fact that personally breaks my sense of self. If you took all the stars in the observable universe and counted them at 1 per second, it would take roughly 50 billion years. That's nearly 4 times the current age of the universe. Every grain of sand on every beach on Earth, every desert, every ocean floor. If every grain were a star, you'd still be short by a factor of around 10,000. That's the universe you live in. And you are roughly 100 trillion times smaller than a single star. I don't say this to make you feel small. I say it because understanding the scale of things is one of the most profound acts of curiosity a human being can perform. Fact number 4. And this one is a genuine mystery, not a solved one, a real, open, unresolved mystery that scientists still argue about today. August 15th, 1977, Ohio, United States. At the Big Ear Radio Telescope, a volunteer astronomer named Jerry Amon was reviewing data printouts from the telescope, looking for anything unusual coming from deep space, and he found something. A signal. Narrowband, at a frequency of 1,420 megahertz. The frequency of hydrogen, the most common element in the universe, which some scientists had theorized would be a logical choice for any civilization trying to broadcast across interstellar space. The signal was so striking that Amon grabbed a red pen and wrote a single word in the margin of the printout. Wow. It became known as the WOW signal. The signal lasted 72 seconds, the maximum length Big Ear could observe any given point in the sky. It appeared to come from the direction of the constellation Sagittarius. It was never detected again. Not once. In over 40 years of looking. Dozens of subsequent searches, including targeted follow-ups by major radio telescopes around the world, have never picked up anything like it. What was it? The honest answer is, we don't know. Some scientists have proposed a natural explanation involving hydrogen clouds. Others are less convinced. No explanation has fully satisfied the scientific community. The WOW signal remains the strongest candidate for a non-terrestrial, non-solar system radio transmission ever detected. It might be the closest thing we have to evidence that someone else is out there. Or it might be nothing. That ambiguity is the most honest thing science can offer right now, and it should keep all of us looking up. Last segment. And I want to end on something that is, simultaneously, the most terrifying and the most freeing thing I know. The universe is running down. This comes from the second law of thermodynamics, one of the most fundamental laws in all of physics. It states that in any closed system, disorder, called entropy, always increases over time. Think of it like this. A neat stack of papers can fall and become disordered, but a pile of scattered papers won't spontaneously stack themselves. Disorder is the natural direction of things. On a cosmic scale, this means the universe is slowly, relentlessly moving toward a state of maximum disorder. All the energy that can do work, powering stars, driving processes, enabling life, is gradually spreading out until it's evenly distributed, and nothing can happen anymore. This is called the heat death of the universe. The timeline is almost incomprehensibly long. Stars will keep forming for roughly 100 trillion years. After that, the last red dwarf stars will burn out. Black holes will slowly evaporate through Hawking radiation over 10 to the power of 100 years. And after that, a cold, dark, perfectly uniform cosmos. No stars, no planets, no processes, no time passing in any meaningful sense. Just equilibrium, forever. And here is the unknown fact that makes all of this beautiful instead of terrifying. Every complex thing that has ever existed, every star, every ecosystem, every thought, is only possible because the universe hasn't reached equilibrium yet. Life is what happens in the gap between order and disorder. You exist because the universe is still interesting. The fact that you're here, thinking, feeling, wondering about dark matter and distant signals and the end of everything, that's not a trivial accident. It's a feature of a universe in the middle of its story. We are the universe, briefly organized, briefly aware, briefly able to ask questions about itself. That's not nothing. That's everything. All right, let's land the plane. Today, 5 more facts that should change how you see reality. 1. Dark matter makes up 27% of the universe. We know it's there. We've never detected it. 2. Dark energy makes up 68%. It's accelerating the expansion of the universe, and we have no idea what it is. 3. The observable universe has 2 trillion galaxies, and it's probably a tiny fraction of what actually exists. 4. In 1977, we received a 72-second signal from deep space that we've never been able to explain or repeat. 5. The universe is running down toward heat death, but you exist in the beautiful, chaotic, improbable window where things are still happening. Science isn't about having all the answers. It's about being honest enough to sit with the questions. If you want to keep breaking your brain with reality, hit subscribe. Every episode, we go deeper. Next time, the speed of light. Why it's the universe's ultimate speed limit. What would happen if you broke it? And the mind-bending consequences of a universe where information can only travel so fast. I'm David. Thanks for listening. Stay curious.